Here we have an assortment of cathode ray tubes. The famous Maltese cross. Unfortunately, this one doesn't work. Then we have a fluorescent tube. The electrons will come down, shine on these, and you'll see them glow. Here we have cathode rays will leave this terminal, shine through the slit, and then shine on a fluorescent strip. And this weird contraption called a Goldstein. Cathode, anode. Electrons are moving up. We now have the apparatus set up properly. Here we have the cathode at the top. The electrons move down towards the anode, which is here, and as they do so, they strike these fluorescent coated pipes. And of course, electrons have energy and they cause these to glow. Let's have a look. Cathode, anode. Notice the effects of a magnet? Notice each fluorescent pipe glows a different color as it's coated with a different substance. They are excited by the electrons coming down from the cathode, striking them as they return to the anode. Here we have an apparatus called Goldstein's canal. Cathode rays come from the cathode. They can't go directly to the anode because there's a glass tube coming up from the cathode inside the apparatus. Instead, the electrons have to move up, go through a series of circular holes in the disc. Then they can come back down through the disc and they form different patterns as they're separated. Let's have a look. As you can see the patterns, these patterns can be manipulated using a magnet. You can chase them around a little bit. Here's a cathode ray tube that shows electrons like to take the easy path. If this were the cathode, electrons would move in one of two paths, either the top or the bottom. But as I said, electrons like to take the easy path. If they move to the top, at this point you may be able to see that we have a cone here. The large opening to the cone is at the left side, and the narrow entrance to the cone is at the bottom side, making it difficult for a number of electrons to enter the narrow end of the cone. On the bottom, it's the reverse. Here we have the large opening to the cone, and then it narrows to a very small exit. And then the electrons could travel to the anode here. If this is the cathode, it makes sense that the electrons should travel through the bottom route. As you can see, the electrons are moving through the bottom path. Now we have the cathode on the left and the anode on the right. So electrons should be moving from left to right. Since the opening on the top has the open-ended part of the funnel on the left and the narrow part on the right, whereas on the bottom the open end is on the right and the closed end or narrow end is on the left, electrons would tend to find an easier path through the top. Let's check it out. As you can see, the electrons in fact have taken the easier path, and you can see the channeling of the electrons. They narrow through the little funnel right here. The open end, closed end.